Hello class, welcome to Algebra Concepts Lesson 3.1, which is all about representing relations. By the end of this lesson, you should be able to represent relations with graphs, ordered pairs, tables, and mappings. Okay, so let's figure out what that looks like. If we are looking at the following points, so if we look right here, we're going to use the points 2, 0, 0, 4, 3, -5, and -3, -5. Those are the points we're going to use, and we are going to display them as a table, a graph, and a mapping. So let's start with the table. You guys have been doing this for a couple of years now, so hopefully this doesn't seem too overwhelming, but just to review, remember an ordered pair is always x comma y, when in doubt, alphabetical order, right? So I would put 2 in the x column, 0 in the y column. Then for the next one, I would put 0 in the x column, 4 in the y column, 3 in the x column, -5 in the y column, and then -3 in the x column, -5 in the y column. And it's really important that like this ordered pair 2, 0, they have to be right next to each other in the table. You can't change the order of the numbers. These two numbers are grouped together, okay? And then the graph, if I'm doing 2, 0, that means I'm going to go right 2 and then up 0. 0, 4 means I don't go left or right, but I go up 1, 2, 3, 4. So here's my next point. Then 3, -5 means I go to the right 3 and then down 1, 2, 3, 4, 5. Remember, I'm always starting at the origin, so that's 0, 0, where the x and the y axes meet. And then for the last point, -3, -5, I'm going to go to the left 3 and then down 1, 2, 3, 4, 5. So that would be right there. And that's how I would represent this relation as a graph. So a relation is just talking about like how an x and a y value are related to each other. Okay, so we can represent it in a table, a graph. You're familiar with both of these. A mapping you've done a little bit before, but not a ton. So let's talk about a mapping. So for the domain, basically you're taking the x part of your table, 2, 0, 3, -3. And if any of those numbers were to repeat, you would just write it once, okay? So now looking at the range, I have 0, 4, -5. And since my last number is also a -5, I don't have to write anything else. I just leave it with the 3 numbers because there are only 3 unique values. Now, just a reminder, the word domain means x, the word range means y. And then for a mapping, you draw an arrow to show like, hey, this 2, it goes with the 0. This 0, it goes with the 4. This 3, it goes with the -5. This -3 also goes with that -5. So you can see that -5 has 2 arrows pointing to it because there were 2 -5s. Okay, so hopefully that doesn't seem too bad for you. Then what we're going to do is the last part is determining the domain and range. And all this is you do a squiggly bracket. So just a reminder, a squiggly bracket, if you do an S, and then a backwards S for the left one. And then for the right one, you do a backwards S and then an S. That sometimes helps students with the squiggly brackets. They don't have to be perfect by any means. Just make sure that I don't confuse it for a number or a letter, okay? So the domain is the x part of your table. It's the domain of the mapping. So you list those numbers. And typically we list them least to greatest, okay? So -3, 0, 2, 3. Am I going to be super picky about this? No. Will I probably write a note on your stuff if you don't put it in order? Yes. Will I maybe make you redo some stuff? Yes. Okay? So squiggly bracket in the range right here would be -5, 0, 4. And voila, I'm all done with the range and the domain. Okay, so hopefully this isn't seeming too bad for you. Now what I want you to do is I want you to list the ordered pairs in the relation. So I want you to type the squiggly bracket. So that is right next to P, okay? And I think you have to hold shift while you do it. So you're going to do squiggly bracket, and then you're going to open your parentheses, list your ordered pair, close the parentheses, comma, open parentheses, list your ordered pair, close your parentheses, comma, open your parentheses, close your parentheses, squiggly bracket. So I just gave you a hint. You should have 3 ordered pairs as your answer here. Good luck. All right, hopefully you said your first ordered pair was 1, 5. So 1, 5. Then you should have said your next one was 5, -1. So 5, -1. Then you should have said -6, -1. So -6, -1. And that's how your answer should look. Squiggly bracket, 3 ordered pairs, separated by commas, squiggly bracket. All right. Now I want you to list your domain for this function. Good luck. All right, some of you maybe wrote 1, 5, -6. Use the squiggly brackets, but remember we're going to write them least to greatest. So the best answer you could give would be -6, 1, 5. Okay, now I want you to do the same thing. I want you to list the range. Good luck. All right, hopefully you said your range was -1, 5. And something I realized I forgot to mention is that even though that -1 is repeated, you only list it one time when it comes to the range. And the same thing would happen for the domain. The domain would only be listed once if a number repeats. All right, now let's look at analyzing a graph. So this graph represents the number of text messages sent by Nora throughout the day. So part A, we want to identify the independent and dependent variables of the relation. So independent, in case you don't remember from last year, is the x value, and dependent variables are our y variables. So in this case, my independent would be my time. So I would say independent variable is time. Dependent would be, I guess I could do an arrow, would be text messages sent. Sometimes I'll have students try to just write independent x, dependent y, and while you'll get partial credit, you won't get full credit unless you write the actual labels for your x and y axes. So make sure you take the time to write what the labels are. So the independent variable here is time, dependent is how many messages are sent. All right, so now let's practice describing what happens in this graph. Okay, so you can see that initially, no time has passed, right? For the first 2 units of time, it goes up really fast, right? Like a lot of text messages are sent, and then going from here to here, it levels off. So that means no texts were sent during that time. Then you can see it goes up a little slower, right? It's not as steep. It goes up a little slower. So text messages were sent, but not as much as the first piece of time. Then it really levels off for a while before the text messages start getting sent more and more as time passes. So I didn't write out everything that I just said, but that's what I'm looking for. When I'm asking you to describe what happens in the graph, I'm looking for something like that, okay? Yes, that much detail. You describe kind of like each part of the graph. You could summarize it a little bit more and say that the number of texts were really rapid at the beginning, then it leveled off, a few more texts were sent, leveled off, no texts were sent before it started trending upward as more texts were sent. So lots of possible correct answers here, but you need to make sure that you describe each section of the graph. All right, question 2. After an airplane takes off, its altitude increases rapidly. Once it reaches the desired altitude, it continues to fly at that level for a short period of time. Then the plane's altitude fluctuates slightly due to turbulence. Finally, the altitude decreases quickly as the plane lands. Which graph best represents this situation? Okay, so I want you to look at graph A, graph B, graph C, graph D, and figure out which one best represents that scenario. Good luck. All right, so hopefully you read this and you said, okay, altitude increases rapidly. Letter C, not really going up all that fast. It's more of a gradual. But A, B, and D, those are all pretty rapid. Once it reaches the desired altitude, it continues to fly at that level for a short period of time. Okay, so letter A, it goes up and it just stays, right? That's not a short period of time. But if we look at B and D, those both level off a little bit. Then the plane's altitude fluctuates slightly due to turbulence. Okay, so if we look, B goes up and down just a little bit, and D goes way up and way down. So that's the slightly is going to tell me that letter B would be the correct answer. Okay, and then finally the altitude decreases quickly as the plane lands. Both B and D match that, but letter B is the only one that has the slight disturbance in altitude. All right, now let's talk about using appropriate scale. So an appropriate scale is like when I give you ordered pairs that are really big numbers and you don't actually want to count up 80 units, right? So maybe you go by tens and you just count up 8 units then. So that's what this whole example is about, is how can you make graphing easier by changing the ordered pairs. So there are a couple steps to finding what would be a good scale. And you guys kind of already do this. This is just me breaking it down further to help you realize that you do these steps already. So step 1, we're going to find what is our biggest and smallest x value. So I have a 5, negative 36, 25, 10, and 1. So my biggest x value is, let's see, or my smallest x value is negative 36, and my biggest x value is, let's see, I think that 25, so I'd say 25. All right, and then my y coordinates, I have 80 as the biggest, and the smallest would probably be that negative 91 right here. Negative 91. All right. So those are my biggest and smallest numbers. So the x-axis should include values from, let's see, I'm going to just go down a little lower. I'm going to say negative 40, and then I'm going to say up to 30 for my x values. Right? Negative 40 to 30, that's nicer than matching 36 and 25, right? And then here, I would say negative 100, because I need to go past that negative 90, up to, I could use 80 if I wanted, or maybe I just make my life easier, and I say 100 to 100. You know what? I'm actually going to make my life easier up here too, and I'm going to say negative 40 to 40, and I'm going to say negative 100 to 100, because those aren't too far. 25 is not that far from 40, and 80 is not that far from 100. So then if I think about this, okay, if I need to go from negative 40 to 40, I should go maybe by tens. And then same here. If I need to go negative 100 to 100, I'm also going to go by tens. So then my ordered pairs, I have 5 and 80. So 5 would be half of a square because it's 10, right? And then 80 would be 1, 2, 3, 4, 5, 6, 7, 8. Or I could have counted that 10, 20, 30, 40, 50, 60, 70, 80. All right, so that's my first ordered pair. Negative 36 would be negative 30. Then just over the halfway mark between negative 30 and negative 40, I'm going to go up to 48. So 10, 20, 30, 40, and then 48 is going to be pretty close to the top. You just have to be ballpark correct. You don't have to be absolutely perfect. I'm not that picky, but you need to be close, okay? All right, so 25 would be 10, 25, and then negative 91 would be negative 10, negative 20, negative 30, negative 40, negative 50, negative 60, negative 70, negative 80, negative 90, and negative 91 is just going to be right below that line. Then I have negative 10 and negative 50, so 2, 3, 4, 5, and then I have 1 and 22, so somewhere in there. All right, so that's all that graphing is. I think you guys can do it. I think you can figure out the scale. I have a feeling you guys are going to be annoyed by this process. You're going to be annoyed at the fact that you have to graph, but look at it this way. Generally, you guys think this is pretty easy. Pretty easy usually means pretty easy points on the test. So let's look at it that way. And if this is hard for you, that's okay. I'm here to help you, okay? So I want you to look at these points and figure out when graphing 1632, negative 10, 11, 4, negative 27, and negative 7, 5, select the most appropriate scale for the x-axis. All right, go ahead and think about that. All right, hopefully you guys picked letter B, and the reason is because negative 10 is my smallest number, and 16 is my biggest number. So if I go from negative 12 to 18, that gives me 1 point on each side of those, and I have scale 2, so evens, that'll make it a little easier to graph. Okay. If you have questions about that, please be sure to ask for some help. All right, now let's talk about choosing an appropriate origin. Okay, so this is again something that you might think is pretty common sense, and it might be something that looks intimidating, but this is me just writing out the things that you guys already think generally. Okay, so the table shows the total snowfall in January for Boston. Okay, so it has the year and it has the total snowfall from 2005 through 2015. So we're going to choose an appropriate origin. So let's talk about what would the label for the x-axis be. X-axis should always be your time. So in this case, it's going to be year. And we can either say year and start our graph like right at 2005, or usually we talk about origins being the number 0, 0. So we're going to say, instead of 2005, we're going to say years since 2005, okay? Because we like our origin to be 0, 0. So we're going to say years since 2005. Let the y-axis represent the, in this case, it'd be total snowfall in inches. Oh, I messed something up. Let me try that again. Grab my pen again. There we go. All right, so then the origin represents, the origin 0, 0 would represent the year 2005 and 0 inches of snow. Okay? So now let's talk about choosing an appropriate scale. The total snowfall is between how many inches? So the smallest number we have, I see a 1 right here. The smallest number is 1 inch, and the highest number, we have 43, and nothing else is higher than that 43.3 inches. So that means that our y-axis should include variables from 0, right? Because we already talked, we have a 0, all the way up to 43.3 would be very precise, but kind of annoying to graph. So let's pick a nice kind of like, you guys tend to like round numbers. So like 45, you could say 44. I'm going to choose 45, and then I'm going to have a scale of 5 inches. Some of you might have said, let's do 44 and have a scale of 2 inches. Your graph's going to be pretty big, even if you do 44 inches with a scale of 2. So when possible, you want to use the biggest scale that you can still graph pretty accurately. Okay, I could show you how to go through and graph all of these using this scale, but I'm going to trust that if you have questions, you ask for some help, and I know that you guys have done some of this already. All right, now, example 5, interpret scales and origins. So this time you're given the information and you need to tell me what it means, okay? So the average number of posts per day on a social media site each year is given in the table. Interpret the meaning of the axes, the scale, and the origin of the corresponding graph of the data. Okay, so we have our table, we have our graph. So let's talk about what do the x and y axes represent. So the x-axis represents, let's not overthink this, it literally tells us right here, years since 2008. Sweet, we're done with that part. And the reason we say years since 2008 is because it's not appropriate to start the year at 0. Okay, so it's really important to have that since 2008. Okay, don't just leave it at years. The y-axis represents the average posts per day measured in millions. Okay, so we have our x and y axes labels. Okay, part B, the scales. Let's talk about what is the scale for our x-axis. It goes from 0, 1, 2, 3. It's going up by 1. So it'd be 1 mark equals 1 year. And if we look here, we have our y-axis is going up by 50s. But it's not just 50, right? It's 50 million posts. So it's really important to write million after that 50, because there's a big difference between 50 and 50 million. So 50 million posts. Then the origin would represent the year 2008, right? That's our starting year. And 0 posts per day, right? Because we have a 0 in that second spot. Okay, so hopefully this doesn't seem too bad. If you have questions at all, please be sure to reach out for some help. I am happy to help you. I hope you guys have a great day.